All right, folks. All righty then. Come on, settle down at the back. Looking at you in the back, in the black. You can sit outside, it's fine. If you want to sit outside. There we go. Thank you very much for your patience. Okay. So my name is Paul Hudson. This talk is called Separation of Concerns, Refactoring View Controllers Live. It'll involve some live coding, because I'm a bit silly like that. Before I do so, a brief overview of who I am. I run a site called Hacking with Swift, cunningly at the URL hackingwithswift.com, easy to find. There has something like 1,200 articles about Swift now, all for Swift 4.2, all online, free of charge. Go and check it out. Earlier this year, I released a new course called Swift in 60 Seconds, teaching the fundamentals of Swift in videos lasting 1 minute or less. I run the annual Swift Community Awards, where you can vote for the people and projects and conferences that have helped me the most over the years. You can go and vote for that at hackingwithswift.com/awards. In August, I released a new app to help you learn Swift interactively on your iPhone. It's called Unwrap. It's on GitHub and TestFlight right now, and go check it out. And with my friend Sean Allen, I run a podcast called Swift Over Coffee. You should all go and subscribe, then even better, tell all your friends to subscribe. My main job is writing books about Swift. Hacking with Swift, Pro Swift, Swift Design Patterns, Vapor. In fact, I'm doing a new one right now called Testing Swift. It's available on Monday. As you can see, I'm busy writing. In fact, if you go to this URL, everyone here can grab one of those books free of charge. It's called Pro Swift. It's good. Get like, I think, 100 videos or so, 6 hours of videos. Go and grab that. 5, 4, 3, too slow. This is how you make friends later on. So you go and find someone's picture of that URL. If you want to get in touch, please do. I am 2 Straws on Twitter. On GitHub, I'm 2 Straws. On Reddit, I'm 2 Straws. But on Stack Overflow, I am 2 Straws. So remember the first bit, you can probably find me. Or email me at paul@hackingwithswift.com. I would love to hear your feedback and questions too. Okay. Today's plan. If you come to events like this and someone says to you, what system architecture do you use? You might be brave enough to say, I use MVC. And inevitably, hilariously, they will say, oh, you mean, haha, massive view controllers, as if they invented this joke. And you're hearing it for the very, very first time, so you kind of laugh along with them, or at least try to. But at its core, MVC is not complicated, right? We know it's fairly simple. Split our code up into 3 components. We have the model, we have the view, and the controller. Where it goes wrong is what we put into the controller. We'll say, well, that's networking, isn't it? And probably business logic and data storage to go in there to controller 2 and delegation and so forth. And you end up with what is effectively a big C architecture. It's all C. Hardly any M, hardly any V. But we're not finished. Of course, that's where you can put animations and I/O and segue and everything else. It all goes in there, because why not? Now, this is partly Apple's fault, right? They've got this really weird definition of MVC they work from. It doesn't match what the rest of the world considers MVC. The Wikipedia definition looks like this. The model updates the view. The controller manipulates the model. How often do we see that in iOS, where our model directly updates the view with MVC? We just don't do it that way. Now, as soon as you saw UI view controller, you should have realized, you should have twigged, something isn't quite right here. Is it a view? Is it a controller? Something else? And in January this year, Greg Letellier at .swift revealed to us all the actual truth here. It was staring us in the face all along. And I think this explains why we fight with view controllers so hard. I should say, please, please share this picture on Twitter. Greg loves seeing his face next to the troll face. He loves it so much. So I think it's fair to say that UI view controller is built on top of some sort of weird sitcom burial ground. We're now cursed forevermore to deal with many and varied weird behaviors and bugs. And worse, by combining the concepts of views and controllers into one thing, we end up with a big ball of mud architecture. Where do you put your code? Obviously, into your view controller. So, in my talk here today, I'm going to be showing you some practical examples, real techniques to help you refactor massive view controllers into sensible view controllers. And it's all going to be live coding, right? Now, you all use Xcode. You know what's going to happen. At some point today, Xcode will go, nope, and refuse to comply. You know what it's like. You'll survive. But without this live coding segment, I'll be just here lecturing you with slides saying, yes, make your view controllers better. That doesn't really help anybody, right? So I'm going to just jump in and show you actual code and really pull things apart in front of you so you can see what's going on. Just very briefly before I dive in, what's in a view controller? Well, like I said, lots of things. You might put your UI in there, you might do model stuff in there, state restoration might go in there, animation, networking, navigation, and more. All sorts of things go into there. In this talk, we're going to look at UI design and, by reference, any animation. We'll look at data sources and delegates, and we'll look at navigation. Okay. And that's it for my slides. Everything else from this point in is going to go wrong with the code demo, so if it goes wrong, you were here to see it go wrong. Yeah. If you want to follow along, please do. This is the URL. You can go and grab a zip file from there with my Xcode project. Go and snag that, or take a picture and snag it later on. Snag it now and code along with me. Come on. Let's see if you can code the fastest. I'm standing up. It's hard to code standing up, you know. So I'm going to go ahead and quit Keynote. And this is where, of course, the comedy will begin. I'm going to try and launch Xcode. And start and Xcode. Hopefully, Xcode will bounce around a little bit. If I move that, there we go. Okay, the resolution is quite low, so might have a bit of comedy around resolution, but we'll get the hang of it sooner or later. Okay, so, gosh, it's very hard to do in reverse. So I'm going to go ahead and inside Xcode, we're going to start by making an actual project so we have something to work with. Now, you already have this Turin zip file. I'm going to extract it on my other desktop and open it up in Xcode. So hopefully it'll launch over in the other window. There we go. Open up the Xcode project. Yes, it's from the internet. Of course it's from the internet. Silly question. Of course it's from the internet. That's the point of it. Where is my mouse cursor? There we go. Come on. Sorry, I was just bending my brain slightly, doing it all in reverse. Where is my mouse cursor? Literally can't see it. Oh, there we go. There we go. It's a super low resolution screen. Okay. There we go. Okay. I'd opened the wrong window. Let's move that over there so everyone can see it. Look at that. Right. Huge big Xcode. Can everyone read that source code more or less? it's pretty big, right? That's good, that's good. I'm not any complaints from the back that it's too small or something, you know. Make it even bigger, yeah, no chance. So this is the project, and you know what it's like launching the simulator the very first time. It's going to be really slow. I have to press Command-R to start building that and launching on the Xcode simulator. I'm using the iPhone XR by the looks of it. So that'll launch, that'll load the simulator and so forth, which means we've got a few seconds to spare. So I'm going to tell you an awful dad joke. Brace yourselves. What is orange and sounds like a parrot? A carrot. Come for the swift, stay for the terrible jokes. Okay, so the iPhone XR is so big, it doesn't even fit on my screen very well, so it's super low resolution. There we go. Okay. So this screen, this application I've built, and this is something I'm obviously working on this in my spare time a great deal. I'm thinking about great apps to build. And this one here is an app teaching folks how to browse through the many online free Hacking with Swift tutorials. And it lists them all in this table view. You can sort of swipe view and see stuff. I'm going to choose names to faces, tells you what you learn, and you can press start reading, and it'll hopefully hit the internet, and it'll totally work first time. Boom, you can then read it online. So there's not a lot going on in this code. But there are some view controllers. So I can see here we have the main view controller class, which is type of code. Here it's, I don't know, 74 lines of code. We have a detailed view controller, which has a bit more code in here, a lot of view loading code in there, 91 lines of code in there. And the read view controller to show the actual web stuff, the little web view hosting thing. With a navigation delegate, it only goes to certain sites, i.e. apple.com and Hacking with Swift. So I want to refactor this code so it's much cleaner, much simpler, much more flexible for the future. And we're going to start off in viewcontroller.swift. That's where the actual app starts, so I want to start refactoring at that point as well. And we're going to start off with a sort of easy method to begin with. You'll see up here is view.load, right? Which is, of course, cool. And the view's finished loading. What do you want to do? And you'll see in here, if I sort of hide this little window, there we go, you'll see it finds the URL for projects.json in the app bundle, and errors out, we can't find it. Then it loads that into a data instance, decodes that into an array of projects, and assigns that into a project constant variable in the property. So that's fine, but this is a fairly common requirement, right? The need to decode something from your bundle and put it into an object in your thing. So rather than having this lurking around in the view controller, I'm going to start by yoinking that out of the view controller and making it shared, reusable code we can all work with. So I'm going to go ahead and select all this code. There we go, all that code there, and cut it to my clipboard. Then press Command-N to make a new Swift file. And I'm going to choose Swift file and name my thing bundle plus decoding.swift. I'm going to put in here a nice generic function to load bundle objects anywhere. So I'm going to say in Xcode, extension on bundle. You'll get a lot of typing sounds to the microphone, I'm afraid. Extension on bundle. A new method here called decode, which will take some sort of generic T that has to be, by its very nature, something decodable. Otherwise, this whole thing wouldn't really work terribly well. We'll define inside there the first parameter, the type it takes, some sort of object type, like that. And then we'll do from file name some string. And it'll return the decoded T, whatever that happens to be. Inside there, I'm just going to go ahead and paste all that code I got. So I've just basically thrown all that thing from my view controller right in there, and it's kind of correct. It's not brilliant. You see it references, project.json and so forth. So I'll just make that say instead file name, and do in here not JSON but nil. Then we have failed to locate project.json. I don't think so. That's going to be instead string interpolation with /parens file name, and the same thing down here. We have failed to load project.json, paste that in there. Then we have loaded project. I'm just loaded now because it could be anything. And then we'll do return loaded. And that more or less is correct. I make one more slight change here. It has to decode the type of what we decode, not project.self, so we'll just do type. Boom. In theory, there we go. Okay. So I've just taken that code out of the view controller so we can now decode anything from the bundle, which is a much, much nicer way of working. But back over here, of course, you have to actually still decode something. So rather than having this this variable at the top here, var project equals this thing, I'll take that out instead say, let projects equals bundle.main.decode, array of project.self, just like before, from projects.json. Boom. Lovely. Otherwise, identical. Press command run, hopefully it'll play it back. Watch it crash because I've screwed something up. Did that take long? No, it did not take long to do it. Can't find file name. Can't find project.json. Oh, yeah, I've totally wrong. Oh, projects.json. If that's the worst bug I have today, that'll be pretty easy. So you're getting it live. You don't get these kind of things recorded videos, do you? No, you don't, Paul. There we go. Otherwise, unchanged. Okay, and it's constant too. It's even better. We like constants, don't we? Constants are a good thing. Okay, so what else is shared functionality? Well, in our code, we have down here, blah, 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 we have this method here called make attributed string. This takes some project data like its title and subtitle and formats it nicely with certain colors and bold and so forth, right? This is transforming some model data into some different model data. NS attributed string is not view, it's model data. So we don't really want that in our view controller. If you have any else in our app that ever wants to use the same formatting, we'll have to use the same functionality. So we can yoink that out and put that somewhere else too. Question is where? Now, there are two options. If you're a view model kind of person, fine, you make a view model, wrap around it and do a view model. Alternatively, make our model understand how to transform itself into different models. I don't really mind what you use. You know your app better than I do. We only have time here for one, so I'll take the easiest one, which is basically yoinking that directly into the model. So I'm going to take this whole method out of the view controller, like that, and then go to project.json, the model for my thing and give it that method instead. It makes it a bit of changes are required, I think. I prefer something like this being a computed property rather than a method, and something like attributed title, returning an attributed string. There we go. Otherwise, it's sound. We'll probably get a few complaints. Let's press build and see what it complains about. Yeah, it's complaining because over here we're calling the method still, which no longer exists, which is fine. We can now say project.attributed title. Build and run. Yeah, okay, fantastic. Easy peasy. Next up, what remains in here, in this view controller, is table view stuff mostly. You'll see it is a table view controller. So it behaves by default as the data source and delegate for our table. So we have a number of sections, we have a number of rows and sections, self row at, and did select row at. So it's, all that's left is table view stuff. Now, of the two of those things, realistically, the data source is significantly easier to extract out and put somewhere else. Because you might want to have the same table data being loaded and shown somewhere else, so you can make reusable data sources very, very easily. Let's do that now. So in here, I'm going to press Command N, make a new CocoaTouch subclass. Subclassing NS objects, fine. I'll call this thing project data source. Data source. Source. There we go. Next, and create. And all I'm going to do is make this thing conform to the important protocol, which is, in this case, UI table view, enable view data source. Like that. Why are you complaining at me? Oh, I haven't played the proper. Yeah, let's do that as well. Let's take these methods from there and put them directly into the method. So I'm going to take all these things here. So number of sections, number of rows, and self-row at all come out of there, out of the view controller, and into our new beautiful isolated subclass of NS object. I'll press build, and it will complain heavily because, of course, I haven't done the right refactoring yet. So now we're no longer a subclass of table view controllers. We no longer have to have these override keywords everywhere, which is safe enough to do. Just take out those things, there, and there. Beautiful. Second up, we're referencing this projects array, which we no longer have access to. That belongs in the view controller, not in the data source. What can we do? Well, we could either load it twice, we could pass it in with an injection, but in this case, I think it makes more sense for data source to own that data. It's a data source, right? It should own the data itself. So rather than having it twice, I'm going to take it out of the view controller and put it into the data source. So this whole thing here, this whole constant property, is going to come out of there and into our data source. So it understands what projects are, and only understands. And now, those build errors appear to have gone away, which is fantastic. But we still have a different build error because over here, in the main view controller, we're referencing the projects array, which we can no longer do. It's inside data source. So we can either sort of dig into the data source and read it out if you want to. Probably not a good idea. A better idea is to create a little getter method to work it in a nice way. So back in our data source, I'm going to add a new method. We'll do func project at index int returns a project, and then we'll just do return projects index. Okay. So now, rather than saying directly project index path, I'm going to say data source dot project at the index path. Much, much cleaner without that extra square bracket there. Okay. Is that going to compile cleanly? Thinking. Still a slight problem. We haven't given it a data source property yet. So we now have a class with data sources and a class with view controller. The final step is to link the two together. Tell the view controller, when you're created, have a data source. So I'm going to say, let data source equals a project data source. And inside view did load, say table view dot data source equals that data source. Build and run. Succeeding. Yeah, I love it. Okay, still look the same, which is a good thing. That's our goal here, right? Okay, so now viewcontroller.swift started out with like 73, 74 lines, and now it's 32 lines. I'm going to leave it there. We'll come back to it later if there's time, but I'll leave it for the time being. It's good enough for now. Next up, I want to look at detail view controller. So in the project navigator, let's try and find detail view controller. Boom, okay. So this creates its views in code, which broadly I'm okay with, right? Use storyboards, use code, I don't really care, it's your code, right? But it does commit a cardinal sin. It creates its views inside the viewDidLoad method, which is not what that method's there for. That's to be shown, to be called, after your view has finished loading, not when you want to start loading your view. So it's a wrong place for it. We don't want any of this code in there. In fact, what I'm going to do is select the whole chunk of code here, all of it, down to the end of the method. There we go. All this stuff here, and cut it to my clipboard. So I've got it floating around my clipboard now. We don't want it there. It does not belong to our view controller. It's not the view controller's responsibility to figure out views. That's the view's responsibility. A smarter idea, a better idea, is to use that mystical V in the MVC acronym, the view layer. So I'll press Command-N to get another new type, a subclass of UI view. And I'll call this thing detail view. And then create that. Yes, it's fine. And this will hold our code for making that detail view. All that stuff we had in the view controller before. So we'll start by having init frame, which is what we're using in the code. I'm going to paste all the code in there. Now this will have a few errors in there because you'll think it has like, view.this and so forth. So I'll get rid of the view there, and there's one here. All these view dots are no longer needed anymore. View there, view there, view there. Command B anymore. Quickest way to find it, quite frankly. It's anger at that, which is fine. We'll come back to that in a second. Anger at that, that's also fine. Fine. It needs init coder, it doesn't need init coder. So we'll do init coder, which is loading from storyboards, which we're not going to be using here, so I'll just do fatal error. I don't think so. Okay. So we still have some compiler errors, right? We've got rid of all the view dots and so forth. But this thing has to know what to fill itself with. It's trying to read like project.topics, what you'll learn, and project subtitle and project title and so forth. It has to have these information provided to it somehow. And rather than using init frame, a nicer thing to do is to pass it the project to load directly. So we can say, I'll give you the project you're designed to configure yourself for, like that. So it'll know the project to use. And now when I press compile, it should be a lot better, in theory, because all those things about title and subtitle and so forth, it now knows what they are. It's being provided to automatically and so forth, which is really, really nice. But we still have a problem. Now, if you look at the way the button works, down here it's got show button, add target, selector, read project, for, touch up inside, right? Trigger something when the button has been tapped. So how do we communicate from this view back to the view controller when the button's been tapped? Of course, there are no end of options. You could use a responder chain, you could use delegates, you could use closures and so forth. Personally, when working with 2, 1, maybe even 3 callbacks, I use closures. If it's more than that, I might not, but for a small number, I prefer closures, keep it more specific and control what's going on. And we'll do that here. What we're going to say is to our little class here, we're going to say that you're going to have a property inside here, which is called readAction. And this will be a function that accepts no params, whoops, too many parentheses, accepts no params, and returns void, like that. It's optional, so it might be provided. So we'll tell you what to call when your button's been clicked. And we can inject that with our initializer. We can say, hey, there'll be a project provided. There will also be a readAction closure provided, which will be escaping, of course, it'll be called later on. And it takes no params and returns void, like I said. And now inside there, we can go ahead and stash that away. Self.readAction equals readAction. We'll need to call super.init. Otherwise, it'll get very angry. In fact, we should probably give it a frame. Frame will be just .0 is fine. There we go. And because we've made this in code, we have to give our view a background color as well, because that's done by IB normally. We're not doing that anymore in IB, so we'll just do white. Okay. Slowly getting there. Now, we no longer override initializer, which is fine. That's our custom initializer. That's fine. Take away the init override keyword. Command B. Thinking. It's still complaining. Oh, escaping. Shouldn't be a colon there. Silly. Okay, so we're getting there slowly. So it's still complaining we haven't filled in this read project method. But that's actually trivial now. So we can go ahead and just say down here, obj.c, func, what do I call it, read project, just call read action. It's optional, so you need the question mark as well. Hooray, so that can pass correctly now. And to hook that up, to actually use that in detailed view controller, which of course we want to do, we'll just go back to the view controller again, and I'm going to go up here, add in load view method, like that, and say our view equals a detail view with the project, our project, and the read action, our existing read project function we made, which is perhaps what's being used before. Boom. We can even actually go out and scrap the obj.c from down here. That's not going to need it anymore. So the code is ever so slightly smaller. Fantastic. So far, we have centralized some helper code. We've split off table data sources, and we've now moved some view code into a UI view subclass. Let's now look at readViewController.swift. This is a fairly simple WebKit wrapper that disallows most sites, only allows apple.com and hackingswift.com, all the things Swift developers need, of course. And this isn't very nice, but what it does is it makes this one view controller also a navigation delegate for WebKit. So it can say, am I allowed to go to this site down here? Decide policy for some action. And it'll say, well, get the host being used. Maybe I can hide that sidebar again. It'll say, grab the host out here, and then do our allowed sites? No, allowed sites contain that thing. If so, allow it, otherwise disallow it, and print a message out, and so forth. And that's fine, but again, this is a really useful thing we can spin off and put somewhere else. And if we spin off and put it somewhere else, we can use it somewhere else as well, and change our minds later on. Like having to change your mind in line in the view controller, like if I'm in child-friendly mode, only these 3 sites, otherwise these 10 sites, otherwise these 50 sites, and so forth. It's messy. Having multiple different objects you can switch between is trivial and much more reusable. So I'll press Command-N, make another new file. This will be a subclass of NSObject, and it'll be called navigation delegate. Delegate. There we go. It's gone into the blue thing, not in the blue thing, in the yellow thing. Much better. Okay. This thing is going to import WebKit, and it'll be a WK navigation. Oh, thank you very much, code completion. That one? No. That one? Yeah. Okay, cool. So now I'm going to go ahead and back to my view controller. I'm going to literally paste all this code, right, cut it out of here, cut, and paste it into there instead. Much better place for it. I have to copy across the allowed sites array, which sites I can go to, like that. Boom, let's put that in there as well. It'll build. Okay, that's cool. Okay, so now, rather than having our view controller act as the navigation delegate, which it is doing right now, we don't want that. Instead, we want to have our own delegate as a property. So we'll do navigation delegate equals an instance of navigation delegate, and pass that into our web view. So again, if you want to enable more sites later on, all you do is change that one property to a different instance of an object, and boom, everything updates automatically. And now other web views can use the same navigation delegate. They all point to the same thing, just saving all that extra copying and pasting, which is fantastic. Now, while we're here, we can fix one personal annoyance. This really annoys me a great deal, which is loading URLs. This is an absolute ridiculous mess of code here to load a simple URL. If you've ever seen Suresh Kanalu's talk, You Deserve Nice Things, well, you deserve nice things. It's all about making good extensions on stuff. This is a personal favorite to making extensions on this, quite frankly, because it annoys me how to make URLs and URL requests and so forth. So I'm going to go ahead and select all this code again, and Command-X to the clipboard, press Command-N, make a new file. I'll choose Swift file. I'll call this thing WebView plus loading. And then in here, we will import WebKit and do extension on WK WebView, WebView, func, load some sort of URL string, that, and paste all that in there. We've got to clean up slightly, so you've got this URLs hard coded in there right now, which is not very helpful, so let's take all that out. replace that with our URL string. It should be URL string, not UR string. And then just call load directly. That should be happier. Yeah. And now we can use that in our view controller. So we can say web view.load URL string, that thing. Okay. Yeah. Okay. You deserve nice things. Okay. So now, at this point, we've gone through our view controllers. We've done a first pass through our view controllers. We've sort of fixed the worst offenders, as it were. If you look at the main view controller, it's called view controller, it does almost nothing now, which is great. If we look at detailed view controller, it again does almost nothing. And our read view controller literally does nothing at all. It can't get any smaller, that thing, which is fantastic. But there's still more we can do. I want to get more out of here. And this is another technique I learned from Suresh, coordinators. It lets us take control of our application flow. And it's beautiful because, where we have our code right now in our main view controller, this thing, when we select the table view thing, has to go into the storyboard here, create a view controller by name, do a typecast as that thing, inject its properties here, reach up to its parent view controller and tell it to do stuff. It's a nightmare of code. We don't really want that in our code. With coordinators, you remove flow from your view controllers. You put it into a dedicated flow object instead. It handles that for you, which means view controller A has no idea that view controller B or C or D exists, that it is a flow, that it's part of a flow. It doesn't really care. So you get true isolation between view controllers. Plus, you can do things like A/B testing. You can do iPhone, iPad variations, and so forth. It's absolutely beautiful. I did not invent it. Talk to Suresh. Anyway, so we'll do it here. And the first step to do that is we're going to start off with a nice, simple coordinator implementation. So I'll press Command-N, make a new file, choose Swift file, and I'll make this thing called coordinator. We'll make a protocol that defines what is a coordinator. So we'll do import UI kit. And I'm going to say, if you want to be a coordinator in my project, you've got to have two properties plus a method. So first we'll say protocol coordinator. First property is a navigation controller, something that can push and pop views onto the screen. And it's get set. Now I'll try and hide this left-hand bar again. There we go. Come on, go away. Hide left-hand bar. Go away. There we go. A nav controller, so we can push and pop views freely. Then we'll have an array of children. So we'll do var children is an array of coordinators. These are sub-coordinators for larger apps. We want to say, this part of the thing, that's my buying flow, this is my authentication flow, my login flow, plus one parent coordinator that toggles between all of them. So that's children. We're not using them here, but you might use them in your own apps. And finally, a method, start. When you are ready to take control, go for it. We'll call start on you. You are now in control of the app. That's how it works. So that's what we want to be an absolute minimum implementation of coordinators. I'll now make a concrete implementation of that we can use in our app. So I'll choose a new Swift file, call this thing main coordinator.swift. I'm going to say we've got class coordinator, main coordinator, conforms to coordinator protocol. And hopefully it'll do this for me. There we go. Boom, nav controller, and var children. There we go. Empty array, so I'm not going to use them here. Like that. Those are two properties. We'll need an initializer, so we can make these things somewhere else. We'll do init. This will be passed in a navigation controller, which is a UI navigation controller. Come on. Thank you very much, Xcode. I haven't imported UI kit. Don't worry. That's my fault, not Xcode's fault. Don't worry. I need to import UI kit. Oh, I'd be very, very angry. Import UI kit. There we go. And we'll just do self.nav controller is that nav controller. Finally, func start. And we'll be filling that in shortly. So that's our real concrete implementation of coordinators. We want that thing to have control over our app as soon as the app starts. This does take a little bit of boilerplate. If you're doing iOS code before storyboards come along, you will know this boilerplate. Nowadays, storyboards do all the work for us. But when I'm removing them, they will go away. So I'm going to open up this thing and go to main.storyboard again, which is, where's main.storyboard? There he is. Okay. I'm going to find and delete my root nav controller. I don't want that anymore. Boom. And similarly, in my project settings, I don't want to load main.storyboard when the app launches. I do not want storyboards to bootstrap my app. I will do it myself using coordinators, which is a much, much nicer way of working, as you'll see. So this is all done using our old pal app.delegate.swift, which is here. And inside this thing here, did finish launching with options. That's where we're going to create our app, the bootstrapping stuff. So first we'll make a property. We'll say var a coordinator is an optional main coordinator, which will fill in inside did finish launching. So our boilerplate code inside here starts off by making a nav controller. So I'm going to say let nav controller equals a UI navigation controller, like that. Then create our coordinator as an instance of main coordinator, passing in that nav controller, and then immediately tell it, start. You have control of the application, so it understands what it's doing. Now, as I've removed that main storyboard, we have to bootstrap our app itself. We have to say in here, window equals a UI window with the frame, UI screen.main.bounds. Remember doing this? It was a real joy. Window.root view controller equals the nav controller. Oops, nav controller, and window.make key invisible. Brings back so many happy/unhappy memories. So now we've got to fill in that start method. It's currently empty, right? What do you want to do when this quarter takes control of our app? What should it actually do? And the answer is it should create that first view controller and get it moving, right? Now, when working this way, I nearly always add a really simple protocol to make creating view controllers from storyboards easily. It means you can use storyboard or use code, and it'll just figure it out regardless of the two, which is very nice. So press Command N, another Swift file. This thing is called storyboarded.swift. And in here, I'm going to say, again, import UIKit. And we'll say protocol storyboard has to have one method. If you want to be storyboard, you have one thing, the ability to instantiate yourself as a view controller. And it returns self with a capital S, a version of whatever it is type that called this thing. So it could be our view controller, it could be detailed view controller, we don't really care what it is. It's something that's called this method. And we'll go ahead and make an extension to that immediately, which does all the real work for us. We can just use this thing from anywhere in our code. So we're going to say extension storyboarded, extension storyboarded, where self is some sort of UI view controller. Static func instantiate returns a self. First, we'll convert the class name to a string name. So I'll say let ID equals a string describing self, like that. So if it's called view controller, it'll look for a string called view controller and so forth. Now we can grab our storyboard. We'll say let storyboard equals a UI storyboard. We'll do name is main, and the bundle will be just bundle.main. And finally, return storyboard.instantiate view controller with identifier, that identifier, and I will do a forced typecast to self, because it needs to be the type of thing it's supposed to be loading, otherwise this whole code makes no sense. So that's our code. And the reason this works so very nicely is because if you look in the storyboard again, you will see, if I open up, say, detail view controller, it has the class name detail view controller and the storyboard ID detail view controller. So the class name and the storyboard ID match every time. So as long as we have the class name, we can get the storyboard ID for any one of these things, which is really, really nice. Okay, so now we have that, we can make our view controllers conform to storyboarded. So we can go to our view controller and say, oh, there's so many of these little panels open, this tiny little screen. There we go. We can go in here and say, you are storyboarded. Boarded, like that. And we'll do the same for detail view controller. There we go. You are storyboarded. And read view controller, you are storyboarded. So they're all being loaded from the storyboard now, which is fantastic. There we go. So now we can start to implement that method in our coordinator. So in main coordinator, back here, we can say let VC equals view controller dot instantiate. Make yourself, please. You know how to do it. And then navigation controller dot push view controller VC animated false. So that will jumpstart our app correctly. Now, as long as I haven't screwed up in the last sort of few minutes, which apparently I have, this should all actually work. What did I get wrong? Push view controller, animated foul. Yeah. No. Build and run again. Hopefully this will work. Yeah, okay, great. Now, this hasn't actually helped us yet. We've just moved the work around a little bit. Where it becomes useful is, inside our view controller now, inside viewcontroller.swift, we can start to use that coordinator. Now, if I had more time, I'd show you how to do this with closures. We haven't got a lot of time. We've got 3 minutes. So I'm going to say weak var my coordinator will be some sort of coordinator. In this small project, it's a concrete type. In your own project, probably a protocol or ideally a closure. And we can assign that when this thing's being made. So inside our start method here, we can say vc.coordinator equals self. So it knows how to talk back to its coordinator when it's finished doing work. And now, in our view controller, we can go into here and take out all this code for doing loading and pushing and so forth. So it no longer has to worry about that. I'm going to take all that code out and instead say coordinator, dot show project. I haven't written that method yet, so it'll complain. Back in the coordinator, let's make that method now real fast. Func show a project, some sort of project, returns nothing, paste it in there. We can simplify this code just slightly, get rid of that, get rid of all this stuff here, use instantiate instead, much nicer, boom, boom, and that is no longer optional. Love removing optionality, me, it's fantastic. Okay, fantastic. And you do the same thing again for the other view controller as well. I would love to show you more. I am sadly out of time, so I'm going to whiz back to my slides just real quick, because otherwise it'll be stuck. So let's scrap that and do that. Okay, so I think we got through most of it, actually. We did a few bits at the end, you know, could show how more testable and so forth and how to use closures, but you get the hang of it. We looked at UI design. There wasn't animation, sadly. There wasn't time for that. Data source and delegates, we went through that. Navigation went through that as well. There's one question mark around navigation. You know, it's a great way to start fights, way to put your navigation code. Again, I don't really care. Put whatever you feel like it. The point is the code we've got is now split up, which means it is more testable, more flexible, more reusable, and more maintainable. This is better code. We can write tests significantly more easily now. We can make our view controllers be positioned differently by changing coordinates on the fly at runtime. We can reuse data sources and protocols and delegates by moving them around as needed. And it's more maintainable because it's smaller and simpler to understand. And this bit that remains, those remaining 3, they can probably stay in view controllers. It has to do something, quite frankly. But all the time, we haven't strayed from Apple's MVC. We're still using MVC. There's no MVVM here or anything like that. This is regular MVC. All we're doing is kind of just spreading out our code, splitting things up more sensibly into separate parts. It's the S in Solid, the single responsibility principle. We've made each component responsible for doing one thing. So let's wrap up really fast. To refactor MVC, first, get your helper methods out somewhere else. They shouldn't be in view controllers. That's not what it's there for. Your view code should definitely not be in your view controllers. Get that somewhere else. All your sources and delegates, get that somewhere else. And again, navigation flow. Coordinators are absolutely beautiful. Using coordinators directly or using closures, I don't really mind how you do it, whatever works for you. The point is, the next time you're looking for a place to dump your code, I pray you will not just choose your view controllers. Thank you very much.